Hello everyone. Our talk is there's more than one way to draw a map. We're a meta-class agency. I'm Alexander Gaevsky. This is my colleague Basil Dubyk.
Hi.
We're developing custom solutions for e-commerce, fintech, and other domains using Python 3, Django, and also Flask and FastAPI. In our spare time, we contribute to the open source projects like DjangoCon and Django. This year, we're giving a talk from my living room, not for the conference call, and this is kind of a weird experience. Third-party special services are key parts of the various platforms in different domains. And traveling, delivery, peer-to-peer marketplaces, transportation. And Google recommended itself as a reliable and solid provider, making itself practically irreplaceable part of those services. As time goes by and special integration becomes more and more tight. We were busy shipping features for the client project when in early fall of 2018, our client approached us since the bill for the Google Maps API dramatically grew. Until July 16, 2018, 1,000 additional requests after initial quota of 25,000 of requests cost 50 cents, and it grew to $7 afterwards. Not that we weren't satisfied by the Google Maps, but the estimated costs exceed the client expectations and our budget, so we started to seek for the solutions and prove the existence of full-fledged, flexible and powerful alternative of Google Maps, which Django Spatial project could use. And also the current price spike not only made us to start looking for a replacement, but also to re-evaluate the whole approach of external API usage and treat API limits more carefully. So, but before we go and review alternatives, let's see what special and mapping service consist of. So first of all, it's tile server, which renders map tiles and serves them. Also, it's JS or other frontend library, which allows to render the whole map out of the tiles and display in the browser. And geocoding API, which allows you to get the location coordinates and other geodata, and also reverse geocoding, which allows vice versa get the location name from the coordinates. Basically, nowadays there are open source components which allows you to build all of the parts of the special service. For the tiles server, you could use Tigala, OpenMap tiles, or you could use OS to PGL component by OpenStreetMaps, multi-tile for the Apache, or custom solution by for the Flask to render the to serve the tiles, and Mapnik to render the tiles of the server. There are also plenty JS map libraries, decent ones like Leaflet JS, OpenLayers, and Mapbox.gl. I would mention those ones. Also, there are geocoding API servers like Pilias and Nominating. Let's see what alternatives we have. OpenStreetMaps, Mapbox, TomTom, Here Maps, Location IQ, Grapehopper, Jog, Andy. So First of all, the criteria for the service was reasonable pricing and sufficient free tier. Map widget, customizable markers, and informational model which could display some additional data when you click on the marker. And we had plenty of markers on the map already, so we needed to group them into the cluster, which we already had in the Google Maps. As for the geocoding, we needed both forward and reverse geocoding. Last but not least, we use location autocomplete, and it would be nice to have a similar one on this new service as well. And a native Python SDK would be cool as well. Also, our client platform focuses on the clients in Germany and Austria, so we wanted that the special data for those locations is maximum accurate, and also we needed all labels and everything to be localized in German. And we already had 10,000 of markers on the map, so rendering clusters also needed a good performance. Otherwise, customers would be frustrated when the map loads too slow. So OpenStreetMaps is a good, is a decent service which uses open data. And it's also open source, and it has free pricing. Already has the Python SDK, JS Maps SDK compatible with it, and RESTful API. On the own dataset, which is crowdsourced by the users, and it has localization. The only con is that the data is open and free, but server is not services usage is not free, and then their services run entirely on donated resources, and they have limited capacities. So basically, you as soon as you reach the quote, which is they don't have a hard quote, but as soon as you utilize their services too hard, they would block requests, and they suggest you to deploy your own tile server using, for instance, OpenMap tiles. So next alternative is TomTom. TomTom is Dutch GPS navigator manufacturer, which is widely used in the UA and European Union and North America, and navigation maps software producer. It has a free tier for 2,500 requests per day, which is 75,000 requests per months, and limitation of 5 requests per second for non-tile-based APIs, and 1,000 for tile-based APIs. And flexible pricing, you can pay as you grow, more requests, more costs. Although there are some caveats here, one request equals 1 transactions, but not always accept traffic API tiles and so on and so on. They have a native SDK for Android, iOS, and web, and it supports markers clusterization. RESTful API has forward and reverse geocoding, search, and a dedicated endpoint for autocomplete, and it has localization and uses own dataset. Mapbox allows to use map 50,000 times for free, and It allows to do 100,000 requests to the temporary geocoding API and 500,000 up to 500,000 requests to permanent geocoding API. It has Python SDK, but it's not currently actively developed, and for now. It has mobile SDK for iOS, Android. It has augmented reality SDK, and it has a RESTful API with both forward, reverse geocoding, and autocomplete. And it has localization as well. Here Maps, it's a service run by Here Technologies, which is a Netherlands-based international technology company. Previously, it was Nokia Maps or OV Maps. It's now owned by a group of companies which are mainly automotive, such as Audi, BMW, and Daimler. Here Maps were used by Facebook and by Microsoft Maps. So the pricing is 200,000 transactions per month. It has 5,000 mobile SDK monthly active users, and it doesn't have a mobile native Python SDK. It has JavaScript SDK for building maps, and extensive RESTful API for location discovering, geocoding back, both forward and reverse auto-suggest, location browsing, lookup by ID, reverse geocoding, and localization. Grapehopper. Grapehopper is a German service for roads planning and optimization, and its main focus on this functionality. It has a free tier of 500 credits per day, but only for non-commercial use. It has limited credit count per minute, and cannot use flexible mode. Does not have native Python SDK, does not have Maps.js SDK, and does not have dedicated autocomplete endpoint. The data set is provided by multiple sources, and it depends on the source. You will be billed a different amount of credits. Location IQ. Location IQ has a free tier of 10,000 requests per day, or 2 requests per second, or 60 requests per minute, which leads to 300,000 requests per month. And it has limited commercial use, so you need to add the link to the Location IQ.com site in the application or on your site. So it has bunch of native software development kits for Python, C#, Dart, Ruby, Objective-C, Perl, Kotlin, PHP, Swift, Scala, Rust, Java, Haskell, R, Go, C++, and Clojure. It doesn't have own Maps JavaScript SDK and mobile SDK as well. Although it has forward and reverse geocoding and location search and dedicated endpoint for autocomplete. It has localization, but since it depends on the external data providers like OpenStreetMap, if the data provider translated a particular geodata into the local language, it will be translated on the local location IQ as well, but they don't guarantee that all results will be translated. AND is a Dutch service. It has a free tier of 10,000 requests per month. It doesn't have any SDKs, but it has a powerful and dedicated map tile server. And RESTful API for forward and reverse geocoding, but doesn't have dedicated endpoint for autocomplete. Geog Maps is a French service which does not have a which has free pricing only for commercial, only for non-commercial use. It's 50,000 map use, 10,000 static maps view, and 10,000 place search requests. Doesn't have any SDKs natively. RESTful API has forward, reverse geocoding, allocation search, and dedicated endpoint for autocomplete and localization. The dataset they are using is from OpenStreetMaps, Open Addresses, and GeoNames. So there is a precaution that the credits and transactions and requests, it's not all the same. When you choose the service, you need to carefully read the agreement and the terms of use, because some of the requests to the APIs would cost a few credits, and consequently they will be billed not as one request but as multiple. Finally, we selected here Maps as the replacement of the Google Maps. First of all, because it has a built-in marker clustering, which would allow us quickly to switch to the here Maps and to save our clusters. It has generous free tier, and it has dedicated autocomplete API endpoint, which we use in two places in our platform, and dedicated API endpoints allow you to fetch results only to fetch results and only receive the full location names and location IDs, just the minimum amount of information, and to later on retrieve the details of this particular location. So also based on the Counterpoint research company, Here Technologies was named as the world's #1 location platform, and it has a leading position during the last 3 years. Here Maps has 80,000 sources of data and provides maps in 190 countries in the world. So finally, those combination of the criteria made us choose the Here Maps. So we could now proceed with the immigration, and my colleague would tell you about it.
As you may know, with Google, adding address autocompletion is quite easy, since you just need to include their JavaScript library into your HTML and provide some callback for when the selected address is changed. This is generally everything that you need to do to make it work. I mean that you are fine with the default styling. But this is not the case with Here Maps. They do not provide ready-to-use JavaScript library for these. And so, since we already use a Vue framework in many places in the project, we decided to implement autocompletion with Vue. Means like making requests, showing dropdown, etc. For this, as you can see on the slide, we use simple input to get the place required by the user for the search, and initial value for it will be rendered by the Django and not by Vue. In the request, in general in the query string, in the request for the here maps API, it's possible to set many different settings that are required by a project. And for example, like results language and the countries that will be used for the search and the max result and similar thing. And also, this I think is very important, you can indicate what HTML tag will be used to highlight the results with places that match text typed by the user. Here you can see the example of suggestions from the here maps API. From here, in general, we use just label to show in the dropdown and location ID that we use to get coordinates of the place. When the user adds their equipment to the platform, they can use address autocompletion to select like concrete address. But when we use autocompletion for searching equipment in desirable areas, we limit the results to the ones where only the city matches with the text entered by the user, and you can see this filtering on the slide. Now we are talking about how we draw and use markers. As you know, Google Maps as well as here maps allow you to use custom images for the markers. So the simplest what we can do for the start, we just use the same image for the icon that we used previously with Google Maps. We use the same for the here maps, but we found that performance is not quite good because we use like fancy PNG with transparency and other. So we decided to use SVG instead of PNG. And additionally here now we start to set the marker size and other things. That time we decided to use SVG instead of PNG to improve the performance of marker rendering. And with these SVG icons for markers, we started to indicate needed marker size and anchor point. Now the size of markers depends on the user browser's pixel ratio, and this is very useful to show markers in correct size on high DPI and Retina displays. To show additional info when a user is clicking on the marker, it's possible to use info bubbles. For it, you just need to provide the coordinates and the HTML content. And here's an example of an info bubble. Is very simple, but it shows that you can display all data related to the clicked point on the map. In our case, we show a photo of the equipment, user's profile picture, and score, price, etc. It's possible to style content in the info bubbles by updating CSS classes added by info bubble automatically and by styling custom CSS classes inside the info bubble. And additionally, you can customize your map during initialization by setting needed tiles, and we think that this is very customizable, so probably can be used in any range of requirements. However, after the first part was finished, a trickier one popped up, markers clusterization. This method allows to group markers of one location, hide single markers, and show a group of markers instead for the given scale. When the user scrolls down, group breaks down into the other groups or to the separate markers. Google Maps provide a ready-to-use JavaScript library in the official repo and a couple of examples how you can use it and integrate. Our successor, Here Maps, luckily has built-in markers clusterization under the hood and 3 different algorithms or strategies powering it. It's fast grid, grid, and dynamic grid for different dataset sizes, and we can compare them. The fast grid is an efficient way to cluster large sets of data points, and we use it for the pages where we show search results not related to some concrete place, or when we show all the markers on the map. Grid strategy is slower but has greater precision. We use it for maps on the user's profile pages, and dynamic grid clustering uses the same algorithm of clustering as the grid, but clusters on the viewport basis. It was suited for data sets that are subject to frequent updates, and we don't use it in our project since we do not make updates to the map, since we put all the needed markers to the maps once. We made our own comparison for the different strategies, and we can see that fast grid strategy for a lot of markers clusters appear on the initialized map much faster than with grid strategy. Last but not least, we have multiple different equipment items tied to the same address, so that previously we plugged in an additional JavaScript library which renders markers within the same location as a literal web of markers. With Spiderfire, we used markers in the open cluster as single markers. On click, we show an info window. Since here does not provide the same functionality as Spiderfire, this time we used a different strategy. We just decided to display only one marker and show available gear in the informational pop-up, which appears when the user clicks on a marker. Now in the info window for the cluster, the user will be able to review all the gears by using just arrows. We found this solution even better than what we had with Spiderfire, since previously users can accidentally skip some markers in the open Spiderfire. If there are many of them, they are all the same in general, and now this is not possible. And additionally, we can say that it's possible to use custom cluster icon. In general, cluster icons can be the same as the marker icons, but since cluster groups a couple of markers, it's useful to show a number of markers in the group. And we have achieved this by putting just text part into our SVG template.
Now that we have finished with the front-end migration, we can look at the backend. On the backend, we were using native Python SDK for Google Maps, and now we obviously needed SDK replacement for here maps. It doesn't have Python SDK, but it's not necessary after all. We can quickly wrap around the RESTful API, since we only need 3 endpoints for geocoding, reverse geocoding, and location lookup. Also, there is a nice looking third-party package called HerePy, which is also suitable for here integration, although we use only 3 endpoints, which doesn't seem enough for bringing in another dependency on board. As stated before, auto-suggest endpoint basically returns only location IDs and has minimum information about the location, obviously due to the performance reasons, so we can later on retrieve location details separately. Naturally, there are popular locations, big cities like Berlin, Cologne, Munich, which customers often look for equipment around. And in order to utilize API code more vastly, we could cache location data for those locations. And you can see on the slide this caching implementation in the lookup method. Now we could review some advanced features like spatial search for the Django project. We have a similar one on our platform as well. So there are two choices to implement full text at the same time, full text and spatial search in the Django project. And you could use PostgreSQL as the database engine or Elasticsearch. So for the PostgreSQL, PostgreSQL, you would need PostGIS and obviously GeoDjango. And on the slide, you see that we outlined the simple model and implemented a simple API endpoint for the Django REST framework, which is doing query using a search filter and also spatial search using D within a filter. The implementation for the Elastic, it requires also Django hashtag. And on the slide, you see that we outlined the index class for the Django hashtag and the implementation for the Django REST framework. It looks quite similar, except the query set. We use a separate method, D within, not filter, and the parameters are quite similar. All in all, we don't stick to the your maps as the ideal solution, since there are plenty of decent products available, and we can't avoid Mapbox, who built special JavaScript library supercluster, which shows quite decent performance with millions of points in the dataset. Also, the Leaflet has a marker cluster module, which also allows to build a cluster for the markers. Thank you very much for listening. You can ask your questions or contact us in the Twitter or via the email.
Yeah, thanks.